right, so now we're going to look at functions as graphs. Now remember, we talked about functions before. A function is a relation between two variables where one variable is the input variable and the other variable is the output. Okay, so now we're going to talk about functions as graphs. Remember, a function is just a relation between two variables where one variable is the input and the other variable is the output. The mathy word for input is domain, and the mathy word for output is range. And the nature of the relation, in order to be a function, is that for every input, for each input in the domain, there has to be exactly, not exactly, but only one output or less. So one input in the domain has to point to exactly one or no outputs in the range. So this domain element could point to a triangle. This domain element could point to a star. This domain element could point to a cat. Okay, I ran out of shapes. All right, so the point being that I can't ever have one element in the domain point both to a cat and to a mouse. Okay, so not that I'm an artist, this would never be allowed in a function. Each element in the input can only point to one output in order for it to be a function. All right, so we looked at how to make tables from rules last time, and now we're going to look at how the table and the rule relates to a graph. So let's go ahead and set one up where we get a rule and make a table. All right, so if I'm given the rule y equals 2x minus 3, I can tell by looking that the way we've set this up that this is y as a function of x. So we would say the words, this is y as a function of x. And that means that if I choose an x, my independent variable, I'm free to choose, that's what independent means, I get some y out of it, and y is dependent. So whatever I choose for x will determine what y is. So y is not independent, it's dependent on my choice for x. So I have a function y, I've written y as a function of x, and I want to come up with some data points that I could use to plot a table or plot a graph. So remember, I like this table where I'm going to choose my inputs and I get my outputs. And I'm actually going to choose the inputs for you. 2, 3, 4, and 5. These are the elements of my domain. Let's write that out again. Right? So these are the elements of my domain, and I'm going to use these to calculate the elements of my range. So y equals 2 times 2 minus 3, and so 2 times 2 is 4, take away 3 is 1, so my output would be 1. In the second one, y equals 2 times 3 minus 3, well 2 times 3 is 6, take away 3 is 3. Y equals 2 times 4 minus 3, 2 times 4 is 8, take away 3 is 5. And y equals 2 times 5 minus 3, 2 times 5 is 10, take away 3 is 7. So these are the elements of my range. And you can see that 2 only gave me 1. There was no other calculation that could give me another output for input of 2. I only got 1, that was the only possible output. Well, if I take my input and my output, I get something called an ordered pair. So in this first case, my ordered pair would look like 2, 1. The important thing here is that we remember that the ordered pair is named ordered pair because the order matters. We always write the domain first and the range, the resultant range second. So if I put in a chosen 2, the function or the rule gives me 1, and I'm going to write that as an ordered pair, 2, 1. So the next ordered pair would be I choose 3, I get 3. The next one, I choose 4, I get 5. The next one, or the last one, I choose 5, I get 7. So all of these pairs are the relations that came out of this equation, which is a function. And I can clearly see that it's a function because I don't get this scenario. 2 didn't give me more than one answer or more than one output. 3 didn't give me more than one output. 4 didn't give me more than one output. And 5 did not give me more than one output. So I know I'm dealing with a function. So now let's represent this function as a graph. So I am only going to put the first quadrant, or the part of the graph that has positive x inputs and positive y inputs. Remember, the line that lies down is always the x, and the line up atop is always the y, if the function is written in this form. So the independent variable is always the horizontal axis, and the dependent variable is always the vertical axis. And now I'm going to put a few tick marks because I don't have a nice piece of graph paper in front of me. And I'm going to be as exact as I can, but generally we're not going to do a lot of graphing by putting in tick marks. Labeling will usually take care of that, but in this case I want to show very specifically what we're looking at. So if I were to graph or plot this first point, the 2, 1 point, I know that the domain has to align with the 2 tick marks. So this would be 1, 2, 3, 4, 5, and this would be 1, 2, 3, 4, 5 on the range. So I know that this point, I need a dot or a point that aligns with the 2 on the domain and aligns with 1 on the range. Well, 2 on the domain and 1 on the range intersect right here. So 3, 3, same thing. If I align with 3 and 3, I get that point. If I align with 4 on the domain and 5 on the range, whoops, excuse me, 4, 5, yep. And then if I align with 5 and 7, well, I need more tick marks, don't I? Alright, this doesn't look right. Here's my mistake. I'm sure you saw it the instant I made it. 3 has to align with 3 on the y-axis, so that would be up on the x-axis, over on the y-axis. That looks much better. Looks like what I have. Alright, so that would be graphing this function that was used by choosing independent variables to receive a dependent variable, which I could make, from which I could make an ordered pair that could be graphed on a domain or independent axis and a range or dependent axis. I always think that's the coolest thing about graphing anyway, that I can have a picture, I can have a conversation, which is really what the rule is, and I can have a collection of data that comes from that. And so I can express the same information in so many different ways that all say the same thing but appear and are used different. I think that's the coolest thing. So let's do another cool thing, since I love all of this. We know that we've seen here where I've gone from having a rule to creating data points to graphing data points. But what if what I have or I start with is my graph? What if the first thing I have is a graph, and I have to find my data points and from that find the rule? So let's do that. This time I have a graph to insert. There we go. So I've labeled the axes. This is the x-axis, and this is the y-axis. And now I want to create ordered pairs, then a table, then a rule. So let's write our ordered pairs first. Let's start with this one here. Well, this value aligns with 1 on the x-axis, or 1 on the domain, and it aligns with 0 on the y-axis. The next point aligns with 3 on the domain and 2 on the y-axis. The next point aligns with 5 on the x-axis and 4 on the range. And the last point is the ordered pair 7, 6. Okay, so now I have my ordered pairs. Let's put them into a table. Remember, this first one is my input, right, the domain, and the second one is my output. So I'm going to make a vertical table this time, because since I don't have an equation, notice in these tables, this table that works this way, the horizontal, or I guess this would be the vertical table, I use this table when I have a rule or an equation already, because it gives me a place to work, but I don't have that this time, so I'm just going to go ahead and make my table sideways. So I'm going to put my input and my output on 2 separate rows, and I'm going to choose my domain. So my domain is made up of 1, 3, 5, and 7. And my range, or my output, is made up of 1 points to 0, 3 points to 2, 5 points to 4, and 7 points to 6. So now I've made a table from my graph, and now I have to come up with the rule. So right now it's a little bit of guessy checky kind of things. To figure it out, we'll start building tools for you to be able to calculate the rule using patterns that you see in the or finding patterns that aren't necessarily super easy. But I can kind of tell just at a glance that my input is the same thing, or that my output is the same thing as my input take away 1. So this could be 1 minus 1 equals 0. Well, 3 minus 2 equals 0 is, 3 minus 1 equals 2. So my input take away 1 is my output. 5 take away 1 is 4. So my input take away 1 is my output. And then lastly, 7 take away 1 equals 6. So the pattern holds true all the way across. So now if I put in variables to explain the rule rather than using the actual numbers in my ordered pairs, I could say that y, the output, or let's write it in reverse order so it matches these. I could take the input variable, take away 1, equals my output. And then I like to put the y in front, so y equals x minus 1 would be the rule. So I went from a graph to a set of data to a table, and then I used the table to find the rule. I could do the same thing if I go the other direction. I could say, well, I'm going to use that rule to calculate my data points, and let's see what I get. Well, my domain is 1, 3, 5, and 7. So y equals 1 minus 1, which is 0. Ooh, that checks out. Y equals 3 minus 1 is 2. That checks out. Y equals 5 minus 1 is 4. That checks out. Y equals 7 minus 1, which is 6. That checks out. These points, if I plot them, 1 on the x-axis, 0 on the y-axis. Second one, 3 on the x-axis, 1. But hey, what happened to my numbers? They all disappeared. My tick marks at the bottom. We'll just remember that they're there, and that 5 on the x-axis points to 4, or did point to 4 on the y-axis, and 7 points to 6. So that is graphing in a nutshell.